So far in this unit, we've been working within right triangles, and we talked about in the last video that to solve a right triangle, we can use either the Pythagorean theorem and or basic trig ratios to find all of the pieces. So now what happens is if you have an oblique triangle, oblique just means that there are no right angles, then neither of those methods work. So we can't rely on SOHCAHTOA or the Pythagorean theorem. Solving an oblique triangle requires either the use of law of sines, which is what this video will be discussing, or the law of cosines, which will be in the next video. So here's the law of sines. Law of sines just has these equivalent fractions. And basically, if you do the sine of an angle divided by the side across from it, that will be equal to the sine of any other angle and the side across from it. Okay, and remember for proportions, it doesn't matter if you do the reciprocal of those. That equality will be true. Okay, so let me just do an informal proof just to convince you of why that is true. If I have this triangle ABC, you can see that ABC is not a right triangle. But what I've done is I've dropped the altitude from vertex C. Okay, so we're calling that H for height. So we're going to write an expression for H using angle A, and then we're going to write an expression for H using angle B. Okay, so if I think of angle A and I think of this right triangle that is created by dropping that altitude, then I could say that the sine of A, remember sine of A is opposite over the hypotenuse, and this would be the hypotenuse in that smaller triangle. The sine of A is equal to H over B. If I was doing the same thing for angle B, this H side is opposite and this side is the hypotenuse in this triangle on the right hand side, then I could say that the sine of B is equal to H over A. So far, nothing really new there. That's just doing your SOHCAHTOA. But now what I'm going to do is solve each of these for H. So I'm going to get H by itself. So I'm going to multiply by B over here. So I'm going to get H is equal to B times the sine of A. And over here, I'm going to multiply by A. And H is equal to the A times the sine of B. So now, if I set these equal, I'm going to get B times the sine of A is equal to A times the sine of B. And if I divide both sides by A, that gives me this. And then if I divide both sides by B, I get sine of A over little a is equal to the sine of B over the little side B. And that's just proving the law of sines. Okay. So let's use this. All right, so we have this triangle over here that is not a right triangle. So we're going to find the missing angle X. And notice what we're given. We're given angle 75 and the side across from it. That's very important. I have to have at least one side and an angle across from it in order to use law of sine. Then I need one other piece. So in this case, the other piece I have is this side, and I'm trying to find the angle across from it. All right, so in order to use law of sines, we set that up. So sine of x over 36, and remember I'm doing over 36 because that's the side across from x, equals the sine of 75 over 50. So all we have to do is cross multiply. Well, here what they did is they got the decimal version of sine of 75 first. Then if we cross multiply, we have 50 times the sine of x equals 36 times 0.966, so that's 34.776. And now we're going to divide by 50. So if I divide by 50, that gives me 0.69. So what do we do if I see sine of x equals that? How do I solve for an angle? Remember, you can't type in sine of an unknown angle, so you have to do the inverse sine. So you have to do the inverse sine of 0.69532. And that would give us this angle measure. Okay, so it's just using that formula, setting it up, cross-multiplying, and solving. Okay, so notice that the law of sines can be used when you have two angles on one side. Notice, like, if you have angle side angle or angle angle side. I don't want you to think that I'm trying to show congruent triangles. It's just showing some vocabulary that we're used to. If I have an angle and then the side in between, remember, I have to have an angle on the side across from it. But if I have these two angles, then I could just find that other one by subtracting those two angles from 180. And that would give me angle C, and I would know the side across from it. And then that would allow me to find either side B or side A. Okay? So that's one way we can use law of sines. You can also use law of sines if you already had C and you didn't have B. So that's the side across from it, and then we would have this angle. And that would allow us to find that side. Okay, so for example, here we have two angles and a side, and I have a side across from one of those angles. So I can set up sine of 50 degrees over 12. That should be equal to, here's the other angle I have, sine of 35 degrees over B. So if we cross multiply, I would have B times the sine of 50. I'm just going to do all of the punching into the calculator at the very end. That way I'm not rounding. And then to solve for B, I'm dividing by sine of 50. So B is going to be approximately, I'm going to type this in, 12 sine of 35. Make sure to close your parenthesis after the sine of 35 before you divide. Divided by sine of 50. So I'm getting B is about 8.985. So it's to the nearest tenth, so I would round that up to 9.0. All right, now for C, I would need to know the angle across from it, and we can do that by adding 50 and 35 together, which is 85, and then subtracting that from 180. So this is 95 degrees. So I'm going to use that in order to do law of sines for C. So I can do sine of 50 again over 12. I prefer to use the whole number that they gave me rather than this rounded side. So just be aware of things like that. That's going to be equal to sine of 95 degrees over C. So again, we're going to cross multiply. And divide. And then just type all of that in to your calculator. Just make sure to close your parenthesis after 95. And I'm getting C is about 15.6. Okay, so then we've solved this triangle, even though it's not a right triangle, just using the law of sines. All right, so this one is a nice one. We have an isosceles triangle. Our vertex angle is 30 degrees, and our base measure is 12. They want us to find the perimeter. All right, so we first have to find those base angles. So remember, if I do 180 minus 30, that gives me 150, and I can divide that evenly among these two base angles, because we know those would be congruent. All right, so we have sine of 30 degrees. Remember, that's across from the 12. That should be equal to sine of 75 over either one of those. Those will be the same. All right, so cross multiply. divide. Type that in. And I'm getting roughly about 23.2 for A. So this is 23.2, this is 23.2. So my perimeter would be all of those added up, 12 plus 23.2 plus 23.2. Which if you add all those up, you get 58.4. And it does say to round to the nearest integer, so that would be approximately 58 centimeters for that perimeter. All right, so we've done examples using law of signs, just something to think about. How can we use this in area? How can we use this idea? So remember when we were proving this law of signs, we used h, the height. So the height is useful because we can use that to find the area of a triangle. So this helps us find the area of any triangle. And so if I have any triangle like we had in the beginning, and then drop the altitude, that would be the h, right, the height. So we know area is 1/2 base times height, and the base is c, right? This is the c, the base, and the height, remember we could say was b times the sine of a. So if we put all that together, then I'm going to have 1/2, the base is c, the height is b sine of a, and I get area is 1/2 bc times the sine of a. And that'll work on any triangle. It doesn't have to be right or any kind of special triangle. Okay. Here's another thing you need to keep in mind for next year. You can also use law of signs when you have side-side angle. However, it can give you different results. You could either have 0 triangles that work, 1 triangle that works, or maybe 2 possible triangles. This is called the ambiguous case. So I'm not going to worry about that this year. You'll learn more about that. So let's just master using the law of signs for the other cases we've been using, and then we'll worry about the ambiguous case next year.